All right, I am recording now. So I'm going to give you guys about another, hmm, let's see, another minute or so to graph these inequalities here on the Desmos calculator. Good morning, David. Glad you're with us. You're going to find this assignment and open it up, and it'll say take the quiz. It's not really a quiz, it's just an assignment, but Canvas calls everything of that nature a quiz. And answer these questions. Are these points solutions to this system of inequalities? Desmos.com slash calculator. Yeah, that's what it is. And then you just type those inequalities in on the left-hand side. Yeah, sorry, Thomas, I wasn't very clear about that. All right. So when you put those inequalities into the calculator, this is what you should get. Hopefully yours looked like that. So this region here, this is the intersection of the three inequalities. And notice that this is a solid line and this is a solid line. And then this is a dotted line. So the first question here is the point 6,2 a possible solution to this system? And it is right there. That is definitely right in the smack dab middle of our solution set. The next one is 10,2. 10,2 is right there. And that is clearly not in the solution set. If you missed these, go back and change your answer if you're able to. Are you guys able to do that? Like, can you go back and change your answer right now? You should be able to. 6,4 is this point right here. And I'm going to zoom in on that because it might be confusing. Is that part of the solution set? Does anyone have an idea? Awesome, Jacob. That's exactly right. It is not part of the solution set because the dotted line is not part, it's not a solution. It's right on the edge. 12, 0. So down here in the corner, 12, 0. Solution set? Nope. For the same reason Jacob just mentioned. It's on the dotted line, so not part of the solution set. Yeah. Well, thank you for telling me. Would that be part of the solution set if it's 12, 2? Still not. Yeah. So let me change that. This is 12, 2. Did I get it right over here? No, I did not. 12, 2. All right. Was that Ella or Shady? Or... Thank you, Ella. All right. 2, 0. So that's right there. Let's zoom in there. Solution or not a solution? It's the intersection of two solid lines. Alina, you're right. Solution. That is a solution. 3 2/3, 4. Oh no. 3 2/3. So somewhere in here, somewhere. And 4, oh, is that 3 2/3, 4? Is that what's in the, I did not do that what I wanted to do. Well, all right. Let's see, 3 2/3, 4. If this is 3, whoops. If this is 3 and this is 3.5, then 3 2/3 would be somewhere right about here. 4 would put us right about there. So 3 2/3, 4 is not a solution. That wasn't what I meant to do. I think what I meant to do was this point right here. Would that point be solution or no solution? Right here at the apex. Thomas, solution. So what I would say is, and I saw Alina, I think it was, said no solution. It's on a solid line and a dotted line. Because of the dotted line, it cannot be part of the solution set. Now, I think what I was trying to get at here was sometimes, even though we have a graph, we might need to plug this into one of the equations in order for us to determine whether or not it's a solution. And I didn't do a very good job of that. Sorry. So, right down here, not a solution because this is a dotted line. This one right here, not a solution because it's a dotted line. This one down here is a solution because it's a solid line and a solid line. And I think that's the one that you might have been thinking of right there. When you have two solid lines intersecting, the lines are part of the solution set, and they both have to be solid in order for the intersection to be part of the solution set, Thomas. So like this one right here. Oh, well, that's right in the middle. Anything in here, that's all part of the solution set. Yep. Great question. Thank you. Any other questions or comments before we move on here? Okay, so I can solve and interpret real world problems using linear inequalities. I'm almost ready for the, and I don't know why this did not get in there, Unit 2 quiz. Hopefully you feel like, oh yeah, I think that the Unit 2 quiz, which is about systems of equations and inequalities, yeah, I think I'm getting there. The asynchronous assignment is going to be a review. Next week we have a Unit 2 team test, team quiz, and then we have a midterm coming up as well, which will cover Units 1 and 2. We're going to be talking about linear inequality maximization, look at some word problems, a Desmos, and then we're going to finish the sync assignment for today. Good morning, Hazel. Good morning, Jason. Haven't said good morning to you two yet. Hope you're doing well. This picture is courtesy of Aiden Pratt, who is one of Mr. Mauer's students. I included this picture in the presentation. It's from the Seattle Boardwalk. You may be familiar with this carousel, or it's a carousel of sorts. I think it's enclosed, if I remember right. I've been on that. And then, yeah, so you may be familiar with that area. All right, so 2 weeks to retake Unit 1 quiz this week and next week. If you want to retake it, remember you need to send me that email with a picture of your Unit 1 review. This week we're doing the Unit 2 review because next week we have a team quiz and the async will be a midterm test next week. So we have 2 tests next week, the Unit 2 team quiz and the Unit 1 midterm test. All right. Questions about that? Okay. So we're going to look at an inequality maximization problem. Now, you may it would be good if you have a printer, you should print up the notes that I upload to our Canvas. It's helpful because the graphs are already on there and stuff like that. But if you don't, that's okay. If you have an iPad or a touch screen, you could also upload that document and then you can draw right on it on your iPad or touch screen. So we're going to maximize this equation, z equals 3x plus 2y, based on what we find when we graph these inequalities. So these inequalities will tell us what our possible solutions for x and y are, and then based on that, we're going to maximize our z here. You probably feel like, oh, this is already confusing. I do not know what Mr. White Wolf's talking about. Let's go through it and just relax for a minute, breathe. I think you'll feel okay by the end. All right? But definitely ask questions along the way. So we're going to start by graphing x plus 2y is less than or equal to 10. If I pick 2 points, I can just graph those 2 points. So for instance, I can plug in 0 for x. So 0 plus 2y is less than or equal to 10. So 2y is less than or equal to 10. Divide by 2, y is less than or equal to 5. So when x is 0, y is 5. So that's right here. Is that yellow hard to see? It is. Let me pick a little bit better yellow, see if this works. Is that better? Is that visible? Okay. And then I need to pick a point for my y value. Put in 0 for y. And when I do that, I get x is less than or equal to 10. Ooh. So that means going, let's see, down 5 to the right 10. So that's a slope of 1/2. Do you guys see how I did that? So from this point, if I'm at 10, 0, that would be way out there. But it has to have a slope of 1/2 because I've gone down 5 and to the right 10. So it's a slope of 1/2. So that means I go to the right 2 when I go down 1, to the right 2 when I go down 1, like that. And because this is a less than and equal to, it's a solid line, like that. Now, if I think about the point 0, 0, if I plug in a 0 here and a 0 there, then I will get 0 plus 0 is less than or equal to 10, and that's true. So that means when I shade down here. Questions about that? Yeah, thanks for asking that question. So I saw that here is a point 0.05. I got that right here. Is that okay? Okay, just I plugged 0 in for x, and then I just solved for y. No, you can plug in any point. I maybe plugging in in the second one, plugging in, um, I could have plugged in 2 for x to see, let's see, if we plugged in 2 here, then we would have 2, 2y is less than or equal to 8 after subtracting 2. Then dividing by 2, we would get y is less than or equal to 4. And so then we would see that when x is 2, y is 4. So yeah, you just really need 2 points, and then you can make the line. But the way that I thought about it was I put in 0 for y, so that made this 0. So then I got x is less than or equal to 10, which means I go down 5 and to the right 10, which is a slope of 1/2. Down 5 to the right 10. Oh, it's negative 1/2, excuse me. But negative 1/2, got to be careful there. Okay. The slope is negative 1/2, you mean? Oh, the slope is negative because we're going down to the right. Whenever we're going down to the right, it's negative. Up to the right, the slope's always positive. This part here does not affect our line. The next part is graphing this. And I can write that equation. I could rewrite it. Y is less than or equal to negative 3x plus 15. That shows me that my y-intercept is 15 and my x-intercept, or excuse me, and my slope is negative 3. I can also pretty easily see that if I plug in 5 for x, then my y value has to be 0. Do folks see that? When x is 5, y is 0. So I have a point right here. So with a slope of negative 3, that means here's another point, and here's another point. And because there's an equal sign here, that's got to be a solid line. And then I can plug in 0 and 0, and this whole side's 0, and 0 is less than or equal to 15. So then that means that shading below where the 0, 0 is where I need to shade. So I'm going to shade over here because that's where 0, 0 would make that inequality true. And when a point makes an inequality true, then it has to be included in the solution region for that inequality. So far, so good? Or is this really confusing? I need someone to speak up if you're finding what I'm doing confusing here, if you're willing to. Yeah. Is it where I'm finding these lines from, Thomas? Is that the part that's confusing, or is it the shading? Okay, you see this right here? All I did was subtracted 3x from both sides, and I got this. Is that good? Yeah. Well, what I noticed is that if I put a 5 right here, then this is negative 15, right? Negative 15 plus 15 is 0, so that makes y value 0 when the x value is 5. That's right here. And then I just said, all right, well, my slope's negative 3, so that means that I have to have a point there and a point there. that good? Still, I moved to the left one and up 3, yeah. Because a slope of -3 means either down 3, right 1, or up 3, left 1. Okay. All right, now we have x is greater than or equal to 0. So here is my x is greater than or equal to 0 line, and I'm going to shade to the right of that. X has to be greater than or equal to 0. So that means over here. And lastly, we are going to shade y is greater than or equal to 0. So here's our y equals 0. Greater than or equal to 0 means we shade above that. So up here, like that. So it's kind of hard to see, but there's this line that comes along here, and then this, and that is our solution region for this system of inequalities. And the question then is, how do we maximize z is equal to 3x plus 2y? So we have to look at all of the solution region and ask ourselves, out of all the points in this solution region, this solution set, which one of those will make z biggest? So which points can I plug into x and y that will make z biggest? That's what we're doing. So the ones that we should look at are the ones that are along the outsides. So for instance, this point, this point, this point, and this point. Because we have all linear inequalities, we can just look at the ones around the outside. So does everyone agree that this point is no way going to maximize z? It'll just, z will be 0. Okay, so at the point 0, 0, z equals 0. At the point 0, 5, z will equal, well, 0, 5. So we plug in 5 for y, z will equal 10. At the point 4, 3, z will equal, here's 4, here's 3. This is 12. 3 times 4 is 12. Plus 6. 12 plus 6 is 18. And at 5, 0, right down here, when we plug in 5 for x and 0 for y, 3 times 5 is 15, plus 0 is z will equal 15. So the point that maximizes our z value is 4, 3. Questions? We're more than 20 minutes into. Oh, Sam, yeah, go ahead. Oh, maximize means make biggest. So it's the single point that will make our z value biggest. So our biggest x and y point that will make z biggest. So z is just this, z is really this equation. And we're just curious, when is this going to be biggest, the biggest number? Which are the x and the y points when we plug them in will make z biggest? Yeah. Sam, if we had something like a quadratic here, there wouldn't be no corner points. So a quadratic requires calculus in a way, unless you're just using visual cues. Um, and you can run into way more difficult problems. But with linear inequalities, we just have to look at the corner points of the quadrilateral or the um, whatever shape is created. Great question, Sam. Thank you. Other questions there? I know we're all just waking up right on cue. Thank you. That was so good, Vincent. Um, we're all waking up. So here's what I want you guys to do. Personally, I'm going to go do a headstand against the wall. It gets blood flowing to your brain just about as good as anything. If you can do a headstand against the wall, do that. If not, do something else. But take 30 seconds to a minute to do something and move, please. All right, that does feel good to me. I hope you got a little movement in. Um, the next one we're going to look at is in the sync assignment number 8, I believe. Oh, this was sync assignment number 7. Sorry, I didn't mention that. So in the assignment that we were working on from the warm up, your answer should be 4-3, and you can put that in there right now if you haven't already. And now we're going to do sync assignment, the same one, number 8, and it's called airline tickets. So this is looking at when we have a word problem. An airline offers coach and first class tickets. For the airline to be profitable, it must sell a minimum of 25 first class tickets and a minimum of 40 coach tickets. The company makes a profit of $225 for each coach ticket and $200 for each first class ticket. At most, the plane has a capacity of 150 travelers. How many of each ticket should be sold in order to maximize profits? So they give us a little hints. Let X equal number of coach tickets and Y equal number of first class tickets. So that's where we're going to start. We're going to write some inequalities now. So we need to have a minimum of 25 first class tickets. Remember, first class is Y. So that tells us that Y should be greater than or equal to 25. a minimum of 40 coach tickets. That says X should be greater than or equal to 40. A profit of $225 for coach and a profit of $200 for first class. So if what we're wanting to do is maximize profits, then these two bits of information are really useful. Notice that they actually make more money on coach. I think that's interesting. I don't know if that's true. So let's call our profits P. Whoops, let's use a different color here. Our profits are P, and we want to maximize that. But P is equal to 225 times coach plus 200 times first class, the number of first class tickets. So each coach ticket, we multiply 225, and that will increase our profits. Each first class ticket, we multiply by 200, and that will increase our profits. We want to maximize our profits. There is a capacity of 150 travelers. So we can think about this as saying, well, the number of coach tickets plus the number of first class tickets has to be less than or equal to $150. Does my method for figuring out each of those inequalities make sense for everybody, or does anyone want to ask about one of those? Okay. So now I'm going to grab those equations, copy them, and bring them over to the next slide so that we can work with them over here. All right. Actually, I need a little bit more room later, so I want to make room now. All right, that y is greater than or equal to 25. I'm going to actually do the yellow one last because I think it'll be easier for, actually, I'm going to show something that I think is helpful. All right. Sometimes people like to do the opposite shading, and I'm going to do it. I'm not going to use this. I'm going to do it the opposite way. And I want you to see if you can tell me why the opposite way might be a good idea. So up here in the corner, I'm going to put a shading is opposite. All right. So y is greater than or equal to 25. So here we're going to find 25, which is the y value. This is 10, 20, 30, 40, 50. So 25 is going to be in between 20 and 30. And we are going to shade below that instead of above. I'm gonna do it, and I want to see if you can figure out why by the end, okay? Just trust that it's opposite for now and see if you can decide why I would want to do that. Okay, Thomas? So here, x is greater than or equal to 40. So we're going to do find 40 here. And x is going to be less than or equal to 40 when we do the shading. If anyone has an idea why I might want to do the opposite shading, let me know when you figure it out. You got it, Vincent. Yeah, it's going to be easier to see the region of the solution set. Yeah. All right, now we have this x plus y is less than or equal to 150. So here's what I'm going to do is I'm going to rewrite that as y is equal to negative x plus 1, oh, not equal to, whoops. Let's see, y is less than or equal to negative x plus 150. So we have a grid that is the same in both directions. Each grid mark counts for 10 in our x and our y's. So this negative x is pretty easy, luckily. So our y-intercept's here at 150, and we can just go down along the corner grids to graph this. Okay. All right. And now this is supposed to be y is less than or equal to, so we're going to do greater than again. So because we've done the opposite shading, the solution set is the white part. But you got to be careful. There is one thing that is kind of confusing about this. When you do that, it includes the lines here. It includes the lines, which is counterintuitive because the lines look like they're part of the outside part, not the inside part. But because we reversed them, they have to be part of the inside part. I hope that's clear. All right, so because we want to maximize our profits, we're going to have to look at these corner points there. So this is the point 40, 110. Down here we have 40, 25. And here we have it's looks like it's 110, 20, 125, 25. So does everyone see we do not need to check this point for maximizing profits? It will, of all the points, it will minimize profits. So the question is it better to sell 40 coach and 110 first class, or 125 coach and 25 first class? You should see right away, based on this information, that 225 for coach and 200 for first class means that when we plug in more coach tickets, we're going to make more money. So let's look at profit is equal to 225 times 40 plus 200 times 110. That's going to be the first one we look at. And so I'm going to pull up a calculator here. If you have a PC and you want this Texas Instruments emulator, I can send it to you. Send me an email. It's a great emulator to have. I don't have it for a Mac, and it doesn't work on Chromebooks, so that's kind of terrible. 225 times 40 plus 200 times 110 is 31,000. So that will equal, profits will equal 31,000 in that scenario. If we have profits, profits equal to 225 times 125 plus 200 times 25. In that case, 225 times 125 plus 200 times 25, that's 33,000. So in that case, the profits are equal to 33,125. So the solution that will maximize profits is 125, 25, and that is your answer for number 8. No, the answer is your XY coordinate point, 125, 25. Yep. Which which means 125 coach tickets, 25 first class tickets. Thank you, Ella, for checking. Much appreciated when you guys ask questions. Okay. Does anyone want to ask another question about this? Do you like the shading outside, the opposite shading? Does that work better for folks? I think it's kind of nice. No one cares? All right. Okay. This is going to be number 9, the high potassium fruit bars. You guys probably are wondering to yourself, yeah, which of the fruit bars out there are the highest in potassium? Well, we're not going to find that out, but we're going to have some problem here that's talking about potassium fruit bars. A health food business would like to create a high potassium blend of dried fruit in the form of a box of 10 fruit bars. It decides to use dried apricots, which have 407 milligrams of potassium per serving, and dried dates, which have 271 milligrams of potassium per serving. Dried apricots cost $10 a pound, which is about 3 servings, and dried dates cost $8 per pound, which is about 4 servings. The company would like the box of bars to have at least the recommended daily potassium intake of about 4,700 milligrams, but would like to keep it under twice the recommended daily intake. In order to minimize costs, how many servings of each dried fruit should go into the box of bars? Let X equal number of servings of dried apricots that should go into the entire box, and Y equal number of servings of dried dates that should go into the bars, the entire box. All right. Lots and lots of stuff going on here, right? So what I recommend when you get a problem like this, you distill all these words down into bite-sized pieces of useful information. Oh, bite-sized pieces, fruit bars. Man, I didn't even mean to do that. Wow. All right. You guys were really lucky to be here and witness that. So, anyway, here we are. These are my bite-sized pieces of information for writing inequalities. All right. We have 10 fruit bars per box. That's good to know. The dried apricots have 407 milligrams of potassium per serving. The dried dates have 271 milligrams of potassium per serving. Dried apricots cost $10 a pound. Dried dates cost $8 a pound. One box needs to have at least 4,700 milligrams of potassium, but no more than, really it should say no more than, because it could have that Well, which should it say? Under. It does say under twice the recommended amount. Okay. The reason why I'm making a distinction there is less than does not have an equal to, at least does have an equal to. So there's going to be an equal to in one of them and not in the other. And we want to minimize costs. So turns out minimizing costs is a really important thing to businesses. So we're going to focus there first. Can you guys hear the lawnmower in the background? No? Okay. All right. So the costs equal, well, let's see, X was apricots. All right. So apricots are $10 a pound per serving. So how much per 3 servings? So how much is it per serving? Do you guys see what I did? So we have to figure out the per serving cost of apricots. So it's $3.33 basically. So 3.33 times however many servings of apricots we have. And then similarly, 8 divided by 4 is $2 per serving for dried dates. So the cost of a box of these bars will be however many servings of apricots times 3.33 plus however many servings of dates times 2. However, so that's what we want to minimize is the cost. So here we have one box will have at least 4,700 milligrams of potassium. So we want 4,700. Well, let's do it the other way. 407, that's the apricots, times X, plus 271 times Y has to be greater than or equal to 4,700. Does that orange really mess with your eyes? Is that hard to see? Or is it okay? It looks weird to me. It's good? Okay. All right. Thanks for speaking up. So we want the potassium, the potassium total, that's the potassium total, to be at least 4,700 milligrams. We also want the potassium total to be less than double the total recommended daily allowance. So you see, I just took that, I multiplied by 2 to get this. Okay? The final what? This inequality has to be included because we want the potassium to be at least 4,700 milligrams. This inequality also has to be included because we don't want the potassium to be more than 9,400 milligrams in one box. So both of them have to be there for different reasons. There are 2 more constraints here that we haven't talked about. Can anyone figure out what they are? Well, our pricing is right here. We need to have some apricots or dates in there, right? So x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Both of those things have to be true. One of them could be 0, but they both will not end up being able to be 0. So here are my inequalities that I'm going to be graphing on the next slide. All right, so let's start with an easy one. X is greater than or equal to 0. Here's x equals 0. And again, we're going to do the opposite of greater than or equal to. We are going to do less than, so that we can see that empty space of solution set more easily. Then we will do y is greater than or equal to 0. And again, do the opposite of that. Now here's what we're going to do. We're going to plug in 0 for x, and that will give us our y-intercept. So I'm just going to use my calculator here. So if I plug in 0 for x, then this becomes 0, and I just need to divide both sides by 271. So I'm going to do 4,700 divided by 271, and that will give me a y-intercept of about 17.3. I'm going to estimate it there. So about 17.3 right there. So I'm going to actually put in when x is 0, y is about 17.34. Let's just be really specific. And now when I put in 0 for y, that's going to give me my x-intercept. This will all be 0. So I need to do 4,700 divided by 407. And that gives me 11.55. So down here at about 11.55, so 11.550 will give me another point. And now I can graph those. And if we solved for y, we would have to subtract this. It would be over there. And then if we divided by 271, it would be y is greater than that. So what I want you to see is that it would be y would be greater than or equal to. So that would mean that we would want to shade over here. But because we're doing the opposite, we'll shade over here. All right. So now we're going to do the same thing with our yellow equation here. And I'm going to plug in 0 for x here to get my y-intercept. So I do 9,400 divided by 271. And that gives me 34.68. So let's see, these are by fives. So 34.68. I'm going to move this out of the way. 34.68 is about right there. So when x is 0, y is 34.68. And when I plug in 0 for y, I'll get my x-intercept. So I do 9400 divided by 407. And my x-intercept is 23.10. 23.10 is right about right there. Oops. So that's going to be 23.00. Oh, 10. 23.1, sorry. And 0. All right, now I'm going to graph those. And again, if I solved for y, I would have y is less than that. Ooh, I messed up. That's got to be a dotted line. Let me fix that. See if I can do it this way. I think so. I love working on an iPad. It makes making errors much easier. So now we need to shade above it, which is the opposite of below it. So that's here. Oh, those yellow, those points are hard to read. Let me there. Okay, so our solution set is in here. All right. And what we need to do is we want to maximize, or excuse me, minimize our cost. We want to minimize our cost. Does anybody have an idea of where we should look to minimize costs? Or where we shouldn't look to minimize costs? For instance, if I wanted to minimize costs, should I look here or here if both of those are part of my solution set? Which, strictly speaking, this one isn't, but close. Here or there to minimize costs? Yeah, this one's going to minimize cost better than this one. This will just cost more. So should I look here or here to minimize costs? Yep. So there are really only 2 points we need to compare, here and there. Now remember that per serving, apricots are $3.33 a serving and dates are $2 a serving. And apricots are our X values and dates are our Y values. So which one of those do you think is going to be the better option? Or is it somewhere in here in the middle? So our dates, the Y values, are cheaper. The dates are cheaper. Our Y values are cheaper. So this is going to minimize our costs right there. So what the company might decide is, listen, we're just going to use dates. 0, 17.34 will minimize our costs. And that would be one way to make the decision. However, maybe the bars don't taste very good if they just put dates in them. So they might end up changing their mind about how they want to make their decision. But this is, strictly speaking, the solution to this problem. Okay, these problems take a while. We've gone through two of them. There is one more, community college salaries. One thing that takes time is the graphing. Use Desmos calculator to do your graphing. It'll be much faster. And also you don't have to inverse things then either. I'm going to let you guys work on this Desmos. And while you're doing that, I'll make the groups of it. What's that, Sam? It is the 17.34, or I think it might tell you to round to the nearest tenth, so 17.3. Does it say where to round to, Sam? Yeah, 17.3. Um, so I'd like you guys to work on that Desmos, and I'll make some breakout groups for you. You can go into those breakout groups and chat, work together, and um, when you're done with that, you'll need to finish your synchronous assignment and also do your daily attendance form. So do the Desmos, and if you finish it up, then get started on the rest. I'm going to copy and paste your groups. Remember, next week you have a group unit quiz. Sam, what's up? Oh, I thought you were unmuted, so I thought you might want something in particular. You maybe were just still unmuted from last time. No worries. All right. Desmos, and then working on those other problems. All right? Questions? All right, everybody. As you're entering your breakout groups, I hope that your rest of the day goes well. I will be available in the main room, and I'm going to pop into your individual rooms as well. All right, Hazel, I see it's not letting you in. Let me see what's going on with that. Hazel, so when you click on it, what happens? Group 2, right? There it is again, Hazel. Try it again. Make sure that you're logged in with your PPS account. maybe you're not logged in with your PPS account in there. Hey, Rylan, can you please make sure that you log out of your personal account so we don't run into you needing to get uh yeah, no worries. So I'm not seeing very many people. I'm seeing like 6 people working on the Desmos. I need to see more people in there working on that Desmos, please. The Desmos link I put in here. There we go. I see more people joining now. Thank you. Awesome. So I see people filling out the Desmos. Please do finish that up. And remember that this week we do not have Wednesday all 8 periods. Our weeks are just bumped up. So what we would normally have on Thursday, we have on Wednesday. What we'd normally have on Friday, we have on Thursday. And it's the end of the grading period, quarter 1. These are not permanent grades, but you want to make sure that you're finishing up everything you can. I'm in my asynchronous Google Meet. all day in the afternoons, 12:30 to 3:30. I hope I see you if you have any questions. If you don't need anything, then have a good week, and I'll see you next week. Be well.